is complex zeros and the fundamental theorem of algebra. We are really kind of expanding on what we started in 2.4. Okay? We've already done bits and pieces of this. It's just taking it to a new level. Notice it does say complex zeros. I think Connor pointed out earlier he saw imaginary numbers. Okay, so when we talk about complex numbers, remember complex numbers include imaginaries. Okay, so real numbers are everything except your imaginaries. Imaginaries, we call those the complex numbers. So complex zeros, fundamental theorem of algebra. A polynomial function of degree n has n complex zeros. We've kind of talked about that, right? If you have, say, x to the fourth, how many answers do you expect to have? 4. Now, they're not always all real. Sometimes they're real and imaginary, but there are 4 answers. Some of these zeros may have a multiplicity greater than 1, so they may be repeated. We talked about multiplicity, like the even multiplicities, or where it will just touch the x-axis, whereas the odd multiplicities will cross through the x-axis. When I'm talking about multiplicities, it's the power on the factor, right? Okay. Linear factorization theorem, something we're also going to talk about today. Given the function f of x of degree n, so degree greater than 0, then f of x has precisely n linear factors, where a is the leading coefficient. This is saying that if it's x to the fourth, then there's 4 factors. Okay? The key is some of them might result in complex factors. In other words, factors that involve complex zeros. And then we have complex conjugate zeros theorem. Hold on to this one in your head. We won't use it right away, but we'll want to use it. Given a function f of x with real coefficients, if a plus bi is a 0, then so is its conjugate. Okay, so this is an important one. We'll definitely be talking about this. And ironically enough, I'm teaching the same stuff in Algebra 2 right now. It's really kind of interesting. So, but right here, if a plus bi is a 0, then so is its conjugate. You have to be aware of that fact because they might give you a 0, a plus bi, so say 4 plus 5i. You have to know, be aware enough to say, oh, 4 plus 5i, I need to include 4 minus 5i, because they won't be nice and tell you at the same time. Okay? Put it up, Hannah. Okay. Example 1. Write the polynomial function in standard form. Identify the zeros of the function and the x-intercepts of the graph. So, standard form. What do I mean standard form? No. If this is a polynomial,
I'm just putting it all out there.
Isn't it like
keep going.
plus bx plus c?
Okay, yeah, you need to go one more. So mx plus b if it was linear,
Yeah.
but this is going to be x times x, so this is going to be quadratic. So we're looking at it multiplied out, ax squared plus bx plus c type thing. And when we do that, we're going from highest power to lowest power, right? Okay, so a, pretty easy multiplication, yes? Let's FOIL. X times x, x squared. 2i times x, I write it as 2ix, minus 2i times x, minus 2ix, minus 2i times plus 2i, minus 4i squared. Okay? This is not standard form because there is simplifying that can be done. What simplifying can be done here?
Positive 2ix.
Okay. 2ix minus 2ix is going to cancel.
I squared is actually
Do you remember that minor detail? Major detail, really. Yeah. I squared is -1, yes? So really when we do -4 times -1, it's really going to be +4. So what is this in standard form?
X squared plus
Yeah, f of x equals x squared plus 4. That is our standard form. Okay. This problem also asked us to identify the zeros. So we did standard form. What about zeros?
Do you graph that part?
We're not graphing it. And in fact, in graphing it definitely would not have helped me.
Oh,
Factor it out. Except if we back up to the original problem, it's already factored out, yes? So what do you do with each of those factors?
Set them equal to 0.
Set them equal to 0. Sound familiar, right? So in order to find your zeros, you set your factors equal to 0. So I'm going to set x minus 2i equal to 0 and x plus 2i equal to 0. So when I solve each of those, what do I end up with?
X equals plus minus 2.
Yeah, x equals positive 2i, x equals negative 2i. I have it written in my notes as 2i comma negative 2i. I'm not opposed to plus or minus 2i at all. Both are good answers. And what are these? These are my zeros. Now, Kylie, you asked about, you suggested graphing it.
Yeah.
Would this one work if we graphed it?
No, because I was imagining.
Yeah, my zeros are imaginary. We wouldn't be able to see anything. And so this, we have to have the algebra option here. Okay, that you wouldn't be able to, if you look at standard form, this is x squared plus 4. What is x squared plus 4? X squared is a parabola. What's plus 4 do to it? 4, right? So thus, it's not going to cross the x-axis, thus imaginary zeros. Okay. I forgot what my next question was. I just led you right into it, though. X-intercepts. There are no official x-intercepts here, are there? Because this graph will not cross the x-axis. Your x-intercepts would be any real number zeros, but I don't have any real number zeros. So I'm going to say no x-intercepts. And that is, I'm going to say because zeros are imaginary. And we could confirm this on the calculator, right? Not going to, because you guys know what x squared plus 4 is. You can visualize that. Okay. Questions there? Okay. B. Same 3 questions. What's wrong?
It's a long. Yeah. Why is there 4 of them? I'd probably get lost.
Okay, guys, this is cake.
What?
This is cake. We haven't done examples 2 and 3 yet. This is cake right now. Enjoy this while you can. This is the easy stuff today. Okay? So, okay. Standard form. There's 4 of them. We have to multiply. What's our process here? FOIL, but we're going to go 2 at a time, right? Now, when you do the 2 at a times, it is important that, for instance, in this case, there's a set of conjugates here, right? A negative square root of 2i and a positive square root of 2i. You want to multiply those together as a pair because nice stuff will happen. Stuff will cancel. Kind of like what we did on the last one, right? And then the x minus 3 times x minus 3 would be a pair. So, okay, let's work. X minus 3 times x minus 3. Can we go ahead and simplify it as we go? Are we that talented? X times x is x squared. X times minus 3. Hold on. X times minus 3 minus 3x. Negative 3 times x is another minus 3x. So if I simplify as I go, what's minus 3x and minus 3x? Minus 6x.
6x.
Yeah, I was trying. that's why I just waved you off, because I couldn't figure out what you were talking about.
Yeah.
Negative 3 times negative 3 plus 9. Okay. Are we talented enough to do the next one similarly? You are simplifying as we go.
It's not about talent.
I'm leading you. We can do it. Okay. X times x. X squared. Now, these are conjugates. What do you know?
We cancel it.
Your middles are going to cancel, right? Verify in your head. But we're going to have a plus square root of 2ix and a negative square root of 2ix. You can write those out, or we can save ourselves a line of work and cancel them now. Now, here's the one we have to be careful of. Negative square root of 2i times positive square root of 2i. Negative times positive is a negative. What's square root of 2 times square root of 2? 2. What's I times I?
Oh my gosh, what?
That makes sense.
Now, what's negative 2i squared, though?
Plus 2.
Plus 2.
Shoot.
Because I squared is negative 1, yes?
Math is funky.
Hey, I'm pushing you guys. You're pre-calc. You can do this without multiplying all the steps out. Some of you do this all the time. Some of you are like, you're really pushing me, Mrs. Sargent. That's fine. I'm going to keep pushing. Okay. Now what? Okay. I'm not going to skip the simple. I'm going to multiply it all out. Okay. There's too much going on here for me to try and simplify as I go here. So, x squared times x squared, x to the fourth. And then I'm going to do x squared times 2, 2x squared. I don't know which way you do this, but this is the way I'm opting to do it. So I'm going to take negative 6x and distribute. Negative 6x times x squared minus 6x cubed minus 6x times 2 minus 12x. 9 times x squared, 9x squared, 9 times 2, 18.
Easy.
Easy. Clean it up. X to the fourth. I got that one. What else do you see? Minus 6x cubed plus 11x squared minus 12x plus 18. Tell me if I made any mistakes. Or I'll check my answer key here in a moment and double check we didn't go wrong, right? And what is that I just wrote?
Standard.
That is standard form, yes? Okay. Enjoy that standard form while you can, guys. That's my hint. That was easy. Okay. We also need to talk about zeros. How do I find zeros? Okay. Each factor equal to 0. So, I'm going to say x minus 3 equals 0. X minus 3 equals 0. X minus square root of 2i equals 0. X plus square root of 2i equals 0. What do I list as my zeros? What am I listing?
3. Plus or minus the square root of 2i.
Plus or minus square root 2i. Do I need to list 3 twice? No. Okay, it is a 0. Now, because it has a multiplicity of 2, because it's x minus 3 quantity squared, right? What that means is my graph, if we graph this, If we graph the standard form, my graph is just going to touch. It's not going to actually cross through. It's going to touch like the bottom or top of a parabola. Okay, there's going to be a min or a max at that point. Okay. Those are my zeros. Sorry, this is really sloppy. Hopefully you guys are keeping up. X-intercepts. Three.
Other ones imaginary.
Okay. Plus or minus square root of 2i are imaginary. We're not going to visibly see those. X-intercepts we have to visibly see. And so x equals 3 is my x-intercept. Okay. Now, I told you guys to enjoy that standard form, right? So that's the easy peasy stuff. Okay. We've done a little bit with this standard form previously. We did a little bit last lesson, lesson 2.4 and 2.3 of multiplying stuff out. So look at example 2 with me. Write a polynomial function of minimum degree in standard form with real coefficients whose zeros include -3, 4, and 2 minus I. We technically did this in 2.4. We actually did in 2.3 also. We're just getting more complicated even now in 2.5. Do you know what I'm talking about doing here?
No.
You did on the quiz too.
Oh,
you
it's
did.
where we put those.
What the other ones?
It's basically what we did up here, where we put it equal to 0.
Okay. So
Or not
basically,
Or
Like
we-
it's you.
Yeah.
That's before you put it.
Yeah.
yeah. Okay. So if there is a 0 of -3, what is that as a factor?
X minus plus 3.
Officially x minus -3, but we're all going to say x plus 3.
Then X minus.
There's a 0 of 4. So I'm going to have a factor of x minus 4. And all of a sudden we pause.
I thought just like 2 minus 1 or 2 minus I, but
Okay, but we didn't just put 4 or just -3. We had to do x minus the number, right?
X minus 2.
Okay, so how'd you say that, Sophie?
X minus 2 minus I.
Okay, so I wasn't sure. So here's the deal. We're going to do x minus,
would you put it in?
and we're minusing the quantity 2 minus I. So there's 2 different ways we can write this. For starters, because we're beginners here, I'm writing it as x minus the 2 minus I. Now, what is that going to be equivalent to if you distribute that minus? It's going to be x minus 2 plus I. And when we get to the multiplying this all out step, this is the form you're going to want to have it in. As you become pros at this, you might want to skip the extra parentheses and just go straight here. Now, okay, we're not quite ready to head to standard form yet. What else do we have to know? I mentioned this in one of our theorems up at the top of the paper. I said you have to understand this because they're not going to tell you. Conjugate. Complex conjugate theorem. If a plus bi is a 0, then so is its conjugate. Do we have a complex 0? Yeah. What's the conjugate of 2 minus I? 2 plus I. So we're going to have a fourth 0. They're not going to tell you that. They're not going to say 2 plus I is 0 and 2 minus I is 0. They're going to say 2 minus I is 0, and you have to catch that you need to put the conjugate in there. Now, if I write this out with the double parentheses, it's x minus parentheses 2 plus I. But if I distribute that minus, it's x minus 2 minus I.
So can we just ignore that?
No, we have to multiply them all out. This is massive amounts of foiling. Okay?
Yeah.
Now, it is important, as I mentioned earlier, that x minus 2i, the two i's, you need to multiply those two as a pair together. It's going to be, I don't know, I almost want to use the word ugly, but you're multiplying 3 by 3, so there's going to be 9 terms. But it's going to clean up very nicely to 3 terms for that part. And then we also have to, and then the other pair I would go ahead and do is the x plus 3 times x minus 4. Does that make sense? Okay. So, here we go. On the x plus 3 times x minus 4, you can go ahead and clean up if you want, or you can go ahead and put all 4 terms and then clean up next step, because we're definitely going to have cleanup in the next step for the other one. So, when we FOIL the first two, x squared, then what?
Minus x.
Minus x. Can you guys handle that? It's minus 4x plus 3x minus x minus 12. Okay, you ready?
No.
I'm going to take x, and I'm going to distribute x times everything in the other parenthesis. X squared minus 2x minus ix. Then I'm going to take this negative 2 right here and distribute it by everything in the other parenthesis. Negative 2x plus 4 plus 2i. And then I'm going to take I and distribute it by everything in the next parenthesis. Plus ix minus 2i minus I squared. And you thought the last one had a lot of work. It was nothing. Do you see my point now?
Yeah.
Now, okay. X squared minus x minus 12. Carry it down. Guys, if we have not made any mistakes, all my eyes are going to magically go poof and disappear.
You're right.
Yeah. Magic.
Is it happening?
Mhm.
Minus ix cancels with plus ix. Plus 2i cancels with minus 2i. What about a minus I squared? It doesn't have anybody to cancel with.
Negative 1. She's plus 1.
Oh, shoot.
Minus I squared is going to be minus negative 1, which is plus 1. My eyes are gone.
5.
Which was the reason we multiplied the conjugates. Okay, so let me clean this up now. X squared minus 2x and minus 2x minus 4x plus 4
5.
and plus 1 is plus 5.
Now we gotta. Now we gotta
Now what?
foil these.
We got to multiply again, folks.
Yay.
We're multiplying 3 by 3 again, so we're going to get 9 terms again. But it's going to clean up. Oh, come on, you love it.
Strong.
Okay. I'm going to take x squared times everything in the parentheses. X to the 4th.
Not having room.
Sorry, I should have warned you. Minus 4x cubed. Plus 5x squared. Then I'm distributing minus x. Minus x cubed. Plus 4x squared. Minus 5x. Then I'm distributing negative 12. Minus 12x squared.
What's 12 times
Plus 48x. Minus 12 times 5 is minus 60.
One more. One more.
So.
And now it's the cleanup step.
Oh, jeez.
X to the 4th. Minus 4x cubed minus x cubed is going to be minus 5x cubed. 5x squared, 4x squared is 9x squared. Minus 12x squared is minus 3x squared.
Where'd you get 5x squared?
X squared times 5.
Hold on.
I don't know. Okay, minus 5x plus 48x is going to be 43x minus 60.
Go team.
Standard form.
There you go. Standard form. Notice, because my I terms are conjugates, we do have all real coefficients here. I did not, all my i's are gone. If you end up with i's left, you've goofed. You've made a mistake somewhere, right?
And it's something
This
else.
one, 4.
Okay. So, and technically, if you want to go there, you don't want to hear this, but that was even a small problem compared to some we might do. Okay?
We're
So-
multiplying 4 by 4.
You know, there's a little bit of work with some of these. Now, let's at least set the next one up. There's no way we'll get it multiplied out. But let's set it up. Thoughts? What's the first factor?
X minus 1.
Oh, Connor took the easy one.
X minus 1 again. Oh, wait, never mind.
Just kidding.
I didn't
Okay.
see the plus 2i.
So there's a single x minus 1, x minus 1 to represent the x equals 1. No adding an extra in there. Now, the 1 plus 2i, I'm going to say x minus, and I'm still going to say parentheses, 1 plus 2i. In my next line, though, I will say that that is x minus 1 minus 2i.
My God, there's 5.
Yeah.
Oh my God.
Now, okay, what do we know about 1 plus 2i before we move on?
X.
It's conjugate 1 minus 2i. You need to put that next. You want conjugates next to each other
Yes.
Oh.
when you multiply it. If you don't put conjugates next to each other, your multiplying is going to be a lot worse than what you've seen. Understood? Because things won't cancel initially. So now I'm going to have x minus the quantity 1 minus 2i, which is really x minus 1 plus 2i. Okay? Then we have 1 minus I. X
Oh, yeah.
minus the quantity
Oh my God.
1 minus I. Or it's x minus 1 plus I. But if we have 1 minus I,
I've run out of room.
We have 1 plus I. which is x minus the quantity 1 plus I, or it's x minus 1 minus I. Okay,
She's
guys.
in a big thing. She's writing normal size stuff on a big sheet of paper.
Yeah.
So she's got.
Well, okay, so here is what mine's going to look like when I get done.
I don't know. I think I'm right too.
That's mine.
I've
So-
run out of room at X minus.
We will multiply on Monday. You're welcome to start multiplying now, but we'll multiply on Monday.
Me personally, I
It's
think I'm
okay.
off of Monday.